All right, so in this video, we're getting to the final stations of our journey, of our process. I would like to thank all of you guys for staying till this point. In this video, we're going to be talking about the conics, the most important one for final images, for you guys to create your own images as we get into the conical graphs. So what are conics? These four elements, right? You probably saw parabola early on in this process. And as you guys are going to see, like conics are part of a cone, right? That's like the name is from it, conics. As you can see, we have the circle here, the ellipse, parabola, hyperbola, all of these elements which we're going to be talking about in this video. So the conic standard form, as you can see, the circle, both your x and your y squared, right? And you can see there's your radius squared. Don't worry, I'm going to get deeper in the standard form of this video. That's basically what we're doing in this video. And then let's just see here in the ellipse, you can see that you have an a squared, a b squared, right? And then you can see that you have both your x and your y squared, and it's always equal to 1 here. And parabolas, you can see there's two different forms, one where y squared, one where x is squared. And in your hyperbola here, you can see that it basically follows the same pattern as the ellipse, but you can see it's negative and a plus. And once again, it equals 1. So let's get deep into it. So the ellipse itself, we could either have two types, right? We can have a horizontal or a vertical one, right? Similar to when we're dealing with transformations, the same concept with coordinates. We could either have our major axis where our vertices and our foci will be located, or we can have our minor axis where our co-vertices will be located, right? And as you can see right here, if we have a horizontal graph, that means that our x squared has to be under a squared, right? And if we have a vertical graph, our y squared is going to be under a squared. And in a hyperbola, your a, if you're just trying to distinguish between your a squared or your b squared, it's always going to be your a squared is always going to be the largest number, right? And b squared is always going to be the smallest number. And when you're trying to find c, right, you have to do when dealing with the ellipse, you have to do a squared minus b squared equals c squared, right? The opposite of the Pythagoras. So as you can see, our vertices, we have three major points. As I mentioned, we have our vertices, our foci, and our co-vertices. If you have a horizontal, we're going to have our A for our vertices, right? You have to always to associate A with your vertices, and you're going to add your K, your A, with your H, since you're changing the X coordinate, right? And plus or minus A, right? So you're going to have H minus A, and you're going to have H plus A. And if you have a vertical graph, you're going to obviously do the same, but now you're choosing your Y coordinate. So you're going to have your center, and you're going to subtract your Y coordinate by A and add it by A, right? And then you foci, you have to associate your foci with your C, in which you find A. If you have your A squared and your B squared, you just have to do algebra to say A squared plus minus B squared equals C squared and solve for the C, in which if you have a horizontal, remember your foci and your vertices lie in the same axis. So you're going to add H plus C and H minus C. With your vertical, the opposite. You do K plus C, K minus C. And as your co-vertices is in a different axis, um, in comparison to your vertices and your foci, this time for horizontal, you're going to add B and also always associate B with your co-vertices. So you're going to add K plus your B, K minus your B for horizontal, and then you have H plus B and H minus B for your vertical, right? And as you can see here, if we're trying to graph this ellipse, we're always um, we're always going to here. So we're always going to connect our vertices with our co-vertices, right? Our foci is mostly given direction, but as you can see, we have our vertice here, co-vertice here, vertice here, co-vertice here, and connected. This is the horizontal, and this is the vertical. And as you can see here, I did some work. So you might have a problem like this, and you can find your center, which is always going to be opposite of H, opposite of K. You find your vertice, you find your A, which is the square root of 36, and you know that's going to be your A because it's the largest value, right? A squared is always the largest, and B squared is always the smallest one. And you find that 6, and as you know, that it's under your Y, you're having your vertical graph, right? So you're adding K plus or minus A, and your co-vertices is always the opposite, right? It's not on the same axis, so you're adding H plus or minus A. And remember, it's always going to be the square root of your smallest number, in this case under your x, so it's going to be the square root of 1, which was 1, and your foci a squared minus b squared, so 36 minus 1 equals 35. But remember, you have to take the square root of 35. You go here and you connect and you just translate, you add your points, find your center here, find your two vertices, and find your vertices. And this is how we look in a technological way. Always addition, remember, that's how you can distinguish an ellipse by hyperbola. Oops, sorry, always addition, and this is the form. It doesn't look exactly like this because this is a vertical one and this is horizontal one, but as you can see, it's hard to graph it on board. That's why we use technology. So for the hyperbola, it follows exactly the same form, but this time, if you're trying to find a and b, it's also going to be the form of a squared minus b squared, right? It's not the largest value. So since your minus is to your y, you know that the x is going to be your a squared is going to be under your x, right? Because it's also in the form of a squared minus b squared. So it follows sort of the same path, but this time if we're trying to find c squared, it's not going to be a squared minus b squared. It's going to be a squared plus b squared, exactly like the Pythagorean theorem, right? And then once again, your vertices and your foci lie on the same axis, which would be this one right here. And your b squared is not really important when graphing a hyperbola. We actually don't even use the b value, but it's know when to find a. That's why, since we know in this case, our b squared would have been 21 and our a squared would be 4, because those in the form of a squared minus b squared, and always has to equal 1. As you can see here, your hyperbola is sort of like your parabola, like two parallel parabolas. So this would be your vertice, right? You would find your vertice, your two vertices once again, plus or minus from your center, right here in yellow. And then um, you have, and then you find your vertice, open a parabola to the direction of your foci, which would be right here, the pink, pink, pink. And you don't need your B, right? You don't need your co-vertice. And what you need though is your asymptote, right? As you can see, there's sort of this separation, right? This where these two graphs are approaching to. So once again, you will need asymptotes, right? There will be two linear asymptotes in which you need to try to find, which I'm going to be talking about later on. As you can see, as you can see here, that's how hyperbola looks using technology. Two parabolas with foci vertices. You can see there's a two linear asymptotes. Remember, minus, not plus. That's how you distinguish a hyperbola from an ellipse when functioning. As you can see, the standard form exactly the same. This time we have a minus. So as you can see here, our asymptotes, right? If we have a horizontal graph, that's what changes, right? It's always going to be in the form of y equals plus or minus b over a x minus h plus k. If it was a vertical, the only thing that would change is that it would be a over b and not b over a. And as you can see, you can find your two lines. You're going to have two lines since you have plus and minus, right? Just like your quadratic formula. And once you find them, right? So this would be your two parabolas and your two lines, two linear lines. But they would actually supposed to be approaching here. So as you can see, this was supposed to like approach more in this direction. But as I'm saying, it's harder to graph a hyperbola using the board, right? This part of the parabola should have been opening to here, and it's sort of small opening. But as you can, the goal here is that this hyperbola opens and not touching, right? And not touching, opens until this line, right? So that it doesn't touch, right? So it'll be opening to this direction like that. Right, but I'm just trying to say like this the shape, but this two parabolas would have been bigger. Like here, your asymptote would have been where your parabola exactly is not touching, right? But I'm saying it's a little bit hard to graph it on paper, but that's how it would actually look. It would not touch. It would these two parabolas would have been a little bit wider, right? So now if we're getting into a circle, but once again you have your x squared and your y squared, and now you have your radius squared. That changes. So the difference is now you're always going to have your center opposite of h, opposite of k. But now your r squared, you're going to take the square root of your r squared, which will be your radius, and you just add that value upwards, downwards, left, and right. And that's how you would do it. You would find your r, your radius, your center, and then you would do left, your center, left, right, up, and down. And this is how it looks like using technology. And now when we get into a parabola, this time what changes now, we're dealing with the conic parabola. So we can have a parabola not just opening up or down, but now opening left or right. Um, so what you can see now is that only y or only x will be squared, not both, right? That's what this makes it different from the other functions. And as you can see, you're going to have your 4 here. And your major points when graphing parabola is your vertex, which would be the same, in other words, your center, right? Which would be opposite of h, opposite of k. And now you have your p value. Because in the standard form, you can see, let me go back there. Here, wait, no. Here, you have, no, it doesn't show, but you have a p. The standard form of a parabola is with a p here. So it's basically, it depends. You can say y minus k squared is equal to 4p x minus k h x minus h. So you have to solve for p. So you know that 4p equals 4 in this case, right? Because this is where your 4p would be at. So you solve for p, your p would equal 1. And what p is the distance from your vertex to your foci, right? So you're going to add and subtract. You're going to add um, your p to, well, in this case, as we know, we're going to have, what changes again for a parabola, we have a y squared. If we have a y squared, that means that we're going to have a horizontal graph. This changes from the other ones, because in the other ones, with y squared, you would have a vertical, but for a parabola, your y squared equals a horizontal. So if you have a horizontal graph, in this case, you're going to add your 1 to your to your x coordinate. So now it will equal 3, 2. Your k, your y coordinate, it's going to be constant. And your directrix, it's plus or minus p. So it's basically subtracting now your x coordinate by 1, or subtracting your x coordinate by p instead of adding. So that would be a directrix, which would equal, well, your directrix is always in the equation form. It's always a linear line in the form of either y equals or x equals a number. In this case, we have our horizontal, so we're going to have in the form of x equals, and because we subtracted 1 by our x coordinate, we have the line of x equals 1. You can see here, this would be our directrix, vertical linear line in the form of x equals 1, and you have a sided parabola opening to the right. This would be your foci, spot, parabola opening, and this would be your vertex. Thank you all for watching this video.